Our use of clickers in lectures. This is an updated version of a presentation I gave to the university some years ago after, back in 2006, our school purchased a set of the PRS clickers that you can see on the left-hand side. Although more recently, in fact, for various reasons, our school has purchased a set of the turning point clickers that you see on the right of the screen, which we'll be using here on in. The way we use these is that our students pick up their numbered clicker on the way into the lecture theatre, can use the clicker during the lecture, then can deposit it back in our carrier cases at the end, so we can use the same set of clickers for multiple classes. It means there's no cost on the students to having these, and it means they're readily available. We found them being quite robust, and we found the students quite appreciate using them, actually. And with classes of the order of 100 students, it's quite easy for them to pick these clickers up on the way and put them down at the end. These clickers are a bit like calculators in size, and the lecturer's computer has a wee dongle that's stuck in, and each student's clicker communicates with the lecturer's laptop via radio frequency signals. So the lecturer can ask a question to the class, and then each student can respond using their clicker on a multiple choice A, B, C, D, or indeed in some cases numerical answers. And all those signals come back to the lecturer's laptop, and then can be displayed on the screen for the lecturer and the students to see what members of the class are answering to those questions. So here's an example of a question from a first-year physics course, where the idea here is a camera has been set up to take a sharp image of a distant scene, and then instead it wants to take a close-up picture of two students. What has to happen to where the film is relative to the lens? Not actually directly a factual recall question here. In the lecture we've talked about some ideas of imaging, what things mean. Asking the question this way is not in fact immediately clear what the answer might be. They need to do a bit of thinking, and it helps get our students engaging with the material, thinking about what's going on, committing to an answer, and also in some cases discussing their answers with other people. The whole process is quick and easy. It's a case of saying what the question is, give the answer, and as soon as that polling time is finished, the display is on the screen. Here's another question you can see on the top of the screen from a second-year electricity and magnetism course, where the students are given a number of options, and in this case you can see the bar chart at the bottom as to what the student responses are. Large majority of the students in the class at the time have answered answer 2, which in this case is indeed the correct answer. A few others have answered rather differently. Had we seen more of a spread, then be able to spend more time explaining why people might have got the wrong answers. In this case, with relatively few students getting the wrong answers, I was able then to rather more briefly say reasons why people might have chosen the wrong answers and carry on from there. In contrast, from the same course, here is a question where you can see there's a very large spread of answers from the class. Again, it's not a factual recall question. The idea is there's these pair of conducting spheres connected by a wire, and various things that may or may not be the same at those two spheres. Actually quite a tricky question, and in the past I hadn't realised how tricky it was, and I just said, well, V1 and V2 must be the same therefore, and carried on. The first year I used the clickers, I asked this question and I got a distribution of responses a bit like this, and there was a collective gasp through the lecture theatre when we realised that there was this lack of agreement. For a student who doesn't get the right answer, it's actually quite reassuring to see there are many others in the same position. For me as a lecturer, rather than carrying on regardless as I would have done in the past without knowing this problem, I'm now able to stop doing what I was planning on doing and spend a bit of time in the lecture thinking about this. And in fact, in this case, my response was to ask the students again to think about it, to find someone who had a different answer to them, ideally, and talk through and see if they could find a logical argument that says why their answer had to be right. So we did that one more time, and then more of a input from me in terms of describing why people might think one thing, think another thing, discuss what might be there, and make it into a real learning experience where students get some direct feedback from peers and from me as to what is happening. In the past, we might have asked these questions with a less high-tech method by asking students to raise their hands for questions 1, 2, 3, and 4. An advantage of the clickers is that in principle no other student needs to know what other student says. It also means that the students at the back of the room can't just look at the bright young lady in the front row and just follow her hand. They need to make their own answers here. We find, in fact, our students take these very seriously and also really quite appreciate the use of clickers in the lectures, getting them very much engaged in what's happening, making our lectures, some of our lectures using these things, more interactive for our students than they might have been, more talk in the room at various times in the lecture, and encouraging our students away from a passive receiving of information to actively processing and working with that information. So this idea of asking a question individually, getting the responses, then if there's a spread of responses, going back to the students and asking them to talk with each other and to explain to each other why they think their way of thinking is the correct way, is an element of what's now known as peer instruction. And the person who might have it right can benefit from being able to crystallize their ideas and explanation. A student who might have had the answer wrong can benefit from thinking through those ideas, and I think is now fairly widely seen in the literature as being a good thing. Indeed, this can be taken a stage further, and if students are given exercises and readings to do before the lecture session, then in fact in some places the lecture can be primarily a set of clicker questions and discussions about the more difficult parts, for example, of the material that's there. We've also used these clickers in lectures to, as a brief survey, how fast are we going through the material, is it about right, too fast, too slow, and the likes. You'll see an example of that in a moment in some of our science outreach work, and indeed on a slightly lower key basis in terms of our orientation week quiz for new students in their groups. We've obviously asked our students what they think about these things, and here's a response from a second year class where you see the strong response is positive. There's a few think they're okay, and relatively few think that they are useless. And indeed, we've even had questions in our Student Staff Council saying, when are we going to use our clickers again? They appreciate these things being used and helping their learning. So I think in conclusion, within our school we feel these things are really quite useful. Our students seem to agree. We're aware that they are in use in other schools within the institution and indeed more widely. And hopefully this presentation has given you some idea of what they can do. Thank you.